Forget about Iceberg and Delta Lake. DuckLake might be faster. DuckDB just introduced a new table format named DuckLake. And if you work with data, you've probably heard about the table wars with Iceberg versus Delta Lake over the past few years. No, you haven't? Well, alright, I'll do a quick recap and then we'll dive into the lake, DuckLake to be precise. So whether you're new to table formats or an Iceberg expert, this video is for you. My mission is to make it easy to understand and get started with DuckLake. But first, a little bit of context. So to understand table formats, we need to start with the file formats like Parquet and Avro. But before that, why we as developers should even care about file format? Aren't databases supposed to handle storage for us? Well, yes, originally databases were used for data engineering, and they still are, but there were two main challenges with old traditional OLAP databases. First is the standard vendor lock-in. Data was often stored in a proprietary format and making export or migration really painful. Second, traditional databases weren't always built to scale storage independently from compute. And that's where decoupling compute from storage started to make sense. Instead of relying on a database engine to store everything, engineers started to storing analytical data as file, mainly in open columnar formats like Parquet, on object storage like AWS S3, Google Cloud Storage, or Azure Blob Storage. These formats are designed for heavy analytical queries like aggregations across billions of rows. So this architecture is what we call data lake. Raw Parquet file on blob storage, queried by any compute engine of your choice like Apache Spark, Dask, or of course, DuckDB. But this freedom of separating storage and compute comes with a trade-off. Indeed, you lose database-like guarantees. No atomicity, you cannot just update a Parquet file in place because they are immutable. You often have to rewrite the entire file. No schema evolution, it's hard to remove columns without manually tracking change. And no time travel, you cannot easily query the state of data as of yesterday. And so that's where table formats come in. They sit on top of file format like Parquet and add database-like features. So you have metadata tracking, usually in JSON or Avro, snapshot isolation, and time travel, schema evolution, partition pruning. That's whole features are stored as separate metadata files in the same blob storage system. However, that creates a new set of problems. You generate lots of small metadata files, which are expensive to read over a network like AWS S3. You often need anyway an external catalog like Unity or AWS Glue to tell your query engine where the root folder of that table is and what version exists. So while table format brought huge improvement, they also introduce overhead and complexity, especially around metadata management. So enter DuckLake, a brand new table format developed by the creators of DuckDB. Yes, it's yet another table format, but DuckLake brings a fresh take with its architecture. So first of all, DuckLake is not tied to DuckDB despite the name.
DuckLake is not a DuckDB specific thing, as you said.
Yeah,
It's a standard.
it's a standard.
It's a convention of how do we manage large tables on blob stores that are stored in formats like Parquet in a sane way,
Yeah.
Using a database.
So yeah, it's true that as of today, the easiest way to use DuckLake is through DuckDB. But it's not a technical requirement for DuckLake. Second, unlike Iceberg or Data Lake, where metadata is stored as file on the blob storage, DuckLake stores metadata in a relational database. Yes, so now you understand why the initial context was useful. We kind of are coming back to the database to some extent. So that catalog database can be either DuckDB, great for local use or playground, SQLite, but typically Postgres or MySQL. And you may ask why use a transactional database for metadata? Because these systems are designed to handle small and frequent updates with transactional guarantees. And metadata operations like tracking version, handling deletes, updating schema are small but frequent. And transactional databases are just a great fit for that. Also, the metadata is tiny, often less than 1/100,000th of the actual size of the data. So storing it in a database avoids all the overheads of scanning dozens of metadata files on blob storage. But as for the metadata, the data itself is still stored like other table formats as Parquet on the blob storage of your choice. So you may have understood already based on my previous example, but because of this architecture, DuckLake can be really fast. So let's say you want to query an iceberg table. Here are roughly the operation. You query the catalog to find the S3 path, you scan S3 to get the current version, you download the JSON Avro metadata file, you load the file list. Finally, you can scan the Parquet file. And if you are just updating or reading a single row, that's a lot of round trips. DuckLake flips the script. The metadata is in a database, so a single SQL query can resolve everything: current snapshot, file list, etc. And then you can directly query your data. So no more chasing down thousands of files just to do basic operations. DuckLake supports nearly everything you would expect from a modern lakehouse table format: ACID transaction across multiple tables, full schema evolution, snapshot isolation, and time travel. Full list on the website. So in short, DuckLake architecture is metadata stored in SQL tables on DuckDB SQLite periodically on Postgres or MySQL, and data still in Parquet file on the blob storage. So DuckLake is not just yet another table format, it rethinks the metadata layer entirely. All right, now that we've covered the backstory of tables formats and introduced DuckLake, let's get practical. To run the next demo, you'll need 3 components: where you store your data, where you store the metadata, and the compute engine. And of course, here we'll use the local DuckDB. So for data, we'll use AWS S3. You need a bucket where we have read-write access to this one. For metadata, we'll set up a PostgreSQL database hosted on Supabase. Supabase is a great option if you want to host Postgres. It has full managed Postgres database capabilities, and you can set it up in 1 minute. They have a generous fee tier. Plus, they have an amazing UI with tons of features that we'll use for DuckLake exploration. Once you create an account, you can create a project and retrieve your connection parameters IPv4 compatible there. For the compute, aka the DuckDB client, I'm gonna use the DuckDB CLI. You can install it with one command script or through a package manager like Homebrew if you are on macOS. You can check the link in the description to have full installation information. All right, the first thing we want to do, because we're gonna use AWS S3, is that I'm gonna use the AWS CLI to log into SSO. So I'm just gonna do AWS SSO logging. So that would refresh my AWS credential. Now that it's done, I have a couple of SQL operations. And so I'm gonna launch the local DuckDB client using the CLI. And here I'm just basically having a SQL file and sending those SQL operations to the terminal down using a specific shortcut. First thing I'm gonna do is create a secret based on the credential chain of AWS S3 I just refreshed. And then I'm gonna create a Postgres secret based on the parameters and password I just created in Supabase. Default database name is Postgres, so I'm just gonna create these secrets, and now I can install DuckLake and the Postgres extension. So if you're not aware, DuckDB has a mechanism of DuckDB extension. You can actually explore all the DuckDB extension using this command, and those are the core extension that DuckDB support. There is also the community extensions, but this is part of the core extension, as you can see, and now it is installed. It's gonna be auto-loaded when I'm triggering this command, so you don't need to load it manually. So how about this command? What does it do? The attach command is like attaching another database. Could be a DuckDB database, it could be a Postgres database or a MySQL database. And here we are attaching DuckLake, so using a Postgres database with a DB name Postgres. And I'm naming it Medio Data Lake, and I'm giving a data path. So this is where the actual data is gonna be stored. So this can be a local file path, or it can be an S3 path, an Azure path. So here I create a bucket with a given prefix DuckLake, where I have read and write operation. And before running this attach command, we can explore, what is inside this actual folder. And you can see there is nothing, there is no Parquet file yet there. I'm using the club to list basically all the files that are on this packet. I do have access, so seems as I'm getting a result, so that seems working. All right, so let's create the attach command. And something interesting to mention is that because I create a DuckDB secrets using the DuckDB secrets manager, and by the way, I didn't leak anything, this database no longer exists when you're watching this video. well tried. Basically, DuckDB knows which secrets to pick up when I attach the Postgres database. So let's go for it. So what's happening behind the scene is that DuckDB has created multiple metadata tables. So we can actually look into the Supabase UI, and you can go to table editor, and you see now I have tons of tables here. All the specification of this table you can find on the documentation website. But as you can see, I have, for example, information about snapshot, DuckLake schema, DuckLake metadata. That's the one I wanted to show you, where you can actually see the data path. And DuckLake table, which should be empty because we have no table yet in our database. So now I can use the Medio DuckLake database, and I'm gonna load a CSV file. So this CSV file is about ambient air quality data. And just to show you, so this is hosted on another S3 bucket. You have a couple of information. Basically, those information, PM10 and PM25 are like measure for air quality in a given city. So what I'm gonna do is basically create a DuckLake table based on this CSV file. So let's go. So this dataset is roughly small. There's just 40,000 rows. So now what I'm expected is that I should have metadata in the Postgres database, and I should have data itself as Parquet file in the given location I give it, which is this one. So let's actually check that. We can do now against a blob command, and I should have one or more Parquet file. Here I just have one Parquet file because the data is relatively small. You can expect multiple Parquet file if your data is really large. You can also inspect all the metadata tables directly from the DuckDB client, by the way. You see they're all underscore DuckLake metadata something. And so this is the table that we see. But just for convenience, let's use again the web UI of Supabase. And so now if I go to DuckLake table, now I have an entry of the table that I just created. I have also some information on the snapshot now. You see, I just see the updates because now we have a new version of the DuckLake with one table added. You have also specific comments if you want to see actual snapshot, which actually query those table. And you see I have basically roughly the same information I just showed you. You have also, what is interesting, some column statistic with like mean max value. So these are the metrics for air quality that I just talked before, PN10 and PN25. So this metadata also could be interesting for various things to query directly the metadata with just a SQL. And you can also actually query that from DuckDB directly. All right, let's do another operation now. So what we're gonna do is basically create an ISO 2 country code. So country code can have either ISO 3, so 3 letter, that's one convention, or 2 letter, that's another convention. So I'm just gonna create a new column, ISO 2. And now that it's done, I'm gonna update basically for the country Germany, which is EU, the ISO codes 2 for the column just created. So let's do that. So now I have updated successfully my table. So if I do simple from where the ISO 2, the new column created, equal DE, I should have all the row with Germany, so DU. All right. Now let's inspect against the Parquet file. What would you expect? Because Parquet files are immutable, so we should see more Parquet file. So we have other Parquet file, and we have also delete Parquet file. So if you look at this delete Parquet file, actually what you're gonna get is basically information about the file path and a position. And the path is basically the row position of the data that needs to be deleted. Of course, when I'm doing just a query from there, I'm getting the latest snapshot of my table. So that means also I can do travel time. So here what I'm doing, because I show you that you can inspect the snapshot just like this. And let's say I want to inspect ISO 2 when it was version 1. It's not working because ISO 2 was not existing in the version 1. There was just ISO 3. I created that column after, and as you can see on the version 2. So if I do this, I'm gonna get actually all the columns which are null. And if I had it a condition of where it is not null, I'm just gonna get 0 because it's on the version 3 that I actually updated this column. So now I should get some data indeed with the updates I did before. With this module, I hope you understand all the different concepts about metadata, the data store, schema evolution, update in time travel. There is much more, but that's it for this hands-on today. Let me know in the comments what you think, especially if you are already an Iceberg or Delta Lake user. I would love to hear how you think it compares. DuckLake is still very early in its life cycle, which means it's a great time to get involved. If there is a feature you need, now is the moment to give feedback because the DuckDB team is actively listening. In the meantime, take care of your data lake and I'll see you in the next one.